right, we're going to be looking at 7.3, and there's one of your favorite words. Now, we don't actually have to do a full-blown proof in this lesson. I really would rather this word be the converse, and you're going to see that down below here in these boxes. Today's lesson is the reverse of 7.2. So what they're doing in this lesson is they're going to give you a lot of the same pictures, and they're going to say, do you know if it's a parallelogram? That's kind of where this lesson is going. So all of these things are the same as what we wrote down in 7.2, only now, again, it's just reversing it. So do you see how all these start with show, show, show? I wish it really would have started with, like, if you have opposite parallel sides. Whoops, that's sides. Then what do you know? I really wish that's how they work, because that's kind of how it is in Geo A. So if you have these conditions, can you say it's a parallelogram? So then the answer is yes. Then it's a parallelogram. And I'm just kind of abbreviating here. So this is from the definition. And again, if you look back at literally what we just did yesterday, that is the definition. We're just going backwards, okay? So this one, if you kind of look at the picture, I think it helps. If you have opposite congruent sides, then what do you know? Well, if my opposite sides are congruent, then you must be a parallelogram. So then it's a parallelogram. So again, it's just going backwards. Yesterday's problems always said it was a parallelogram. Today's, they're asking you if it is. It's pretty much the same pictures. So notice the next picture. Do you see how those are opposite congruent angles? So if you have opposite congruent angles, then what do you know? Well, I know it's a parallelogram then, because how else would it fit together? So do you see this word converse keep popping up? Now, kids will always ask me, do we have to memorize the titles like we did in Geo A? And the answer is not 100%. You don't really have to know the titles. It's just, it is extra credit. So if you can fill in the title, you'll get 1 point extra credit. So it's not a huge deal. Don't sit there and stress over it, but it will help your grade if you know them. Okay, so take a look at this last one. We actually did not see this one yesterday. So look at the marks. You only have one set of parallel sides, but then you also have a congruent mark. So in this one, this is kind of a new one, but it's really helpful. If you have, so if one side is congruent and parallel at the same time, has to be the same one. You can't have this though. You can't have congruent and then parallel over here. That's not going to work. They have to be together. So if one side is both congruent and parallel, then it's a parallelogram. So that's a new one. That's kind of a new one, and I will say that's really helpful, okay? And then there's still one more. There's the diagonal one. It just didn't fit on this page, so it rolled onto the other page. So notice up here, that's the diagonal one again. So if your diagonals are, if your diagonals bisect, so I don't want to say equal, but if they bisect, you know, one of them could technically be shorter, but it's split into those pieces. If the diagonals bisect each other, whoops, I almost wrote it twice, each other, then what? Well, then it's a parallelogram. So in the next section, they're going to ask you to state a reason, but again, this part right here, this justification, is extra credit on the quiz and test, okay? So state a reason used to prove whether it's a parallelogram. So really, you just have to say, is it yes or no a parallelogram? Like, do you have enough justification? And then if you can state your theorem or whatever, then you can get the extra credit point. Okay, so here we go. Opposite are parallel and congruent. So that's enough. So you can say yes. And if you do that on the quiz, full credit. But if you can state this name, then you'll get it. Now, I don't care if you abbreviate a little bit, but do not just use the first capital letters of each one, because that's really not enough. So you got to say like opposite sides are both parallel and congruent. And even if you don't put the word theorem, I would give it to you, but I need to know like at least some of it. Now that's one of the only ones that doesn't have the word converse. All the rest of them use the word converse, so you got to watch that. Okay, you look at number 7 and you're like, these are not opposite, so they're not in the right position. So then no, this would not form a parallelogram. And then if you say no, there's no extra credit point. You just say no and move on. So if you want to stop it here and go ahead and try the other 6 from this section, see how you do, and then you can, check your answers. Okay, hopefully you paused it. These 2 look good. So I have 2 5s, but it's this other section that fails. So due to those, I'd have to say, no, this is not a parallelogram. Number 9, I have a 7 and a 7 and a 5 and a 5, and they're opposite. So I'd say, yes, this is good. And this is the parallelogram, opposite sides, converse theorem. Even if you just said opposite sides, converse theorem, that's what I would give you. You don't have to have that word in the front. Okay, 10. I've got opposites congruent, but I need to know about these 2, because what if they're not the same? So I would have to say, no, I don't have enough information. Over here, these 107s look good, but I'm not 100% sure on that one. So I think I would grab my calculator, and I know this is a quadrilateral, so that means it's got a total 360. So if I subtract off the pieces I know, let's see how much we're left over with in that corner. Oh, look at that. Do you see how now my 107s are the same and my 73s are the same? So I would say, yes, this is enough. And it's because you have the opposite angles converse theorem. And do you notice I didn't put the word parallel in the beginning? I mean, as long as, you can give me the most part of the theorem, I'll give you the extra credit point. Okay, 12. 12, you look at this and you're like, these are diagonals. And do they bisect each other? And they do. So then you're like, sweet, this is a yes. And then it's this top one. So again, as long as you can say diagonals, converse, theorem, remember, they're not congruent, they bisect each other, then I would give it to you. All right, 13, I've got the 4s being congruent, but what about the top and the bottom? It's kind of like this one. Only one piece of information is not enough, so then you'd have to say no. I don't know if that's enough. And that's it. Now, number 14 is kind of almost building off number 13 in a way, or number 10. What they're doing is they're only giving you one piece. They're saying if these sides are parallel, what additional piece do you need? So I'm going to draw myself a sketch. It's not a very good parallelogram. Okay, so here's my parallelogram. And it doesn't matter how you name it, as long as you start at one corner, like A, B, C, D. What you can't do is you can't go A, B, and then cross the figure to do C. You just have to start in a spot and then go around the figure. All right, it says AB is parallel to DC. Now it's asking me which one of these 4 do I need? So the best thing to do is just process of elimination. If these are congruent, so if this segment AB was equal to the diagonal, would that be enough? And you're like, no. If this is a diagonal, I need the other diagonal, so this would fail. So then you just have to go through and test which one's going to work, and only one of them works. So now look at the next one. If AB, so if this side, is equal to DC, if these sides were equal, if you had parallel and equal, do you see how it's practically that picture? So then that would be the choice you would want to pick. Now, you might want to try the other choices, but I can tell you, I mean, that is the right answer. These two also fail, but if this one failed, you'd have to go to the next one, and then the next one, and so on, okay? So really, it's just the reverse of what you did in 7.2. So the next three pictures look almost the same as what we did right here with these number ones. They're just saying, we don't know if this is a parallelogram. Do your calculations to show me it's a parallelogram. So again, all you do is you look at these and you say, okay, well, if you're sides, then opposite sides, you must be equal. So then I'm just going to set these sides equal to each other, and I'm going to solve this. And as long as I can solve this, then that means this must be a parallelogram. So if x is 10, that would mean this is 19 and this is 19. So those are opposites. And if x is 10, that means this side is 17, which means y must be 17. And if this is true, then I have a parallelogram. So it's really, you don't do these problems any different than what you did yesterday. The directions don't say it's a parallelogram. So if you want to quickly pause it here and just quick go through and do your calculations, that would be great. Okay, so 16, I've got diagonals, so I'm just going to set these guys equal to each other. Let me quick write this down. Normally, I don't like to move my variable, but I'm just going to subtract the 5x, so then I get x to be 4, which is good because I don't want a negative because I can't have a negative diagonal. All right, number 17. Really, there's a couple ways you can do 17, but just, remember, if you try to do same side, those are different letters, and so you don't really want to do a system. So if you pick A, and you notice if you go across, do you see how it's the same letters or the same variables? So then that's going to make it a lot easier. So we can just make our equation. And then now, again, I don't typically like to move my variable, so it's negative. And then I would just divide by -1 because I know I can't get a negative. You're not going to really see a whole lot of negatives in geometry class because it just doesn't really have a lot of application. Okay, and then the same thing over here. I'm going to take my B and go opposite. And so then if I make my equation, if I subtract my Y, 87 divided by 3, I don't know that off the top of my head, is 29. And then I'm done. Okay? All right, so those are just doing your calculations. Now, the next two are practically the same question, but you have to show. You have to show that it's a parallelogram. So in this one, you're going to have to pick pretty much one of these to decide which one to show. The only one that you really can't pick is this opposite angles, because I don't know how you would actually calculate this angle right here to show that they're congruent. So don't pick that one. And if when we're in class and we're doing this, I'm going to ask you guys like what you want me to show. So I'm going to show two different methods for these, but you could do the same method for both of them. You really, really just have to pick. Okay, so that's, again, it's up to you. So how about this first one? I'm going to show that the opposite sides are parallel. So I'm going to show the definition. So if I'm showing parallel, that means I need to do the slope. So I'm going to do the slope of AB, and I'm going to do the slope of DC. Now, honestly, I can see this. I can just count the slope. So I can just go from here, rise 1, 2, run 1, 2, 3, 4, 5. So I can rise 2, run 5. And I'm going to do the same thing for DC. I'm going to rise 1, 2, and then I'm going to run 1, 2, 3, 4, 5. And do you notice that these are parallel? Okay, I need to do the other sides because if I'm going to do the definition, which is what I picked, then I need to show both of them. I need to show both sets are parallel. So now I'm going to do AD and BC. And again, I'm just going to count. Now be careful, from left to right, this is a negative line. So this is going to be down 1, 2, 3 over 1, 2, 3. So down 3 over 3 is going to be a negative 1. And then I'll count from B to C. So down 1, 2, 3 over 1, 2, 3. So that means these are parallel. And then you're supposed to tell which property that you basically just showed. Now again, I don't necessarily care if you give me the exact formal thing, but what you just showed was really that opposite sides are parallel, which that is the formal, is called the definition of a parallelogram. And again, you don't have to get super specific. Even if you just said opposite sides are parallel, I would give it to you. But I'm kind of needing to know, like, why did you do this? Okay. Now, number 19, obviously it's a different parallelogram. So if I quick graph it, which there's kind of no rhyme or reason why they didn't have this one graphed, other than maybe just making you do a little bit of practice graphing. So here's your parallelogram. You could do the slopes of them again and do the exact same procedure. Again, you just have to pick. So on this one, just to practice a different formula, how about I do this one? Now, if we're in class, I'm going to ask you guys. So I'm going to do that the diagonals bisect each other. And remember, that means then, like what we kind of did over here, is that they're going to cross at the midpoint. Okay? So what I'm going to do is I'm going to do the midpoint of the diagonals. Now this one I'm not going to be able to count. I am going to actually have to calculate it. So when I do the midpoint of AC, so this one's AC, I got to just watch my numbers here, okay? So I'm going to add my x's together and divide by 2, and then I'm going to add my y's together and divide by 2. So that's going to give me 2 divided by 2 and 3 divided by 2. Now when I do, oh here, I can draw this in. That's this diagonal. When I do the other diagonal, when I do this one, it better be the same midpoint or I've got a serious problem, okay? So now I'm gonna do the midpoint of BD. So that's gonna be this pink one. All right, I'm gonna add my x's together, so 4 and negative 2, and then I'm gonna add my y's together. That's 2 divided by 2, and that's 3 divided by 2. Do you see how my midpoints are the same? So then I'm showing the diagonals converse theorem, okay? So you could say midpoints are the same. I would give you that. If you want to be more formal, it's the diagonals converse theorem. And it's just this one right here. It's that one. Okay? So I need to see your work, and then I need to see some type of a little bit of a conclusion. Like, what does this tell me? What does this mean? Like, what does it mean? You know, maybe I even should say something about bisect. The midpoints are the same, so they bisect. You know what I mean? Or something like that, okay? All right, there's one more problem, and it's just kind of an application problem. You don't have to show any work, but it's just an application. So you're trying to find some other missing vertices of this parallelogram, but you're going to use some of the same concepts. So why don't you pause it and try this one before I go over it? But this is the last one. Okay, so hopefully you tried it. Now, this is the diagonal meeting point. So this 0, 1 is the midpoint, okay? One of them is located at 2, 4. Another one is located at 3, 1. Now, this is the midpoint. So that means these two must be connected. That means the other part of the parallelogram would be over here, because think about, if this is the diagonal, it would have to go like that, right? So what if we just calculated the slope? What if we calculated how far do you go over and down? We could do the same thing from the midpoint. So I went over 1, 2, and then I went down 1, 2, 3. So over 1, 2, down 1, 2, 3. So one of my points is -2, -2. Because that's going to be a midpoint of the diagonal. Now, the other one, if you kind of look from the end point to the midpoint, do you see how that's a straight line? That means it's a slope of 0. So you really are doing slope, but in a way you might almost think of this as distance, like how far away are they? I really couldn't do that on this problem because of the angle it's on. But because this is horizontal, I can just do 1, 2, 3, 1, 2, 3. So my other point would be that. And if I just quick finish off my parallelogram here, that's the parallelogram. And then do you see how I've got the midpoint dead in the center of it? So that concludes 7.3.